Hey BC Calc kids. Today we're working on integration using tables and other miscellaneous things such as reduction formulas. And so you're going to have some reference pages in the back of your book, and you can go to the table of contents on your ebook and just go all the way down to the bottom where it says appendices. And so you'll look at all these rules that you have. I think there's about 75, but there are many more formulas that mathematicians have come up with. You just have a short list there just to explain that if you do need a formula, it's probably out there somewhere, or maybe you'll use your calculator. Either way, hope you're doing well today, and let's take a look at some of these problems then. So I looked in the back of your book, and the reference number was Rule 24, that is this formula. So what you try to do is you try to look at the equation or the integral that you have and try to fit it to the formula that you're looking for. And you notice that there's an x to the fourth, which is squared, and there's a constant, which is also a square. And you have to remember that sometimes when you have a plus 2, 2 can be the square root of 2 squared, right? So it doesn't always have to be a perfect square, or even, it doesn't have to be a perfect square. But anyhow, so the way I started this, I said it doesn't look exactly like what I want. So I'm going to let a equal 3. And so it'll be an x dx integrand over 3 squared plus x squared squared. And that quantity squared at the bottom. So I'm going to first do a u sub here. So I already have that written out. And then I have a du is equal to 2x dx. And then du over 2 is equal to x dx. And so I now have the integral then of x dx is then equal to 1/2. I'm going to pull the 1/2 out front. And then I have a du, make that a little bit bigger, du over 3 squared plus u squared, and that's all going to be squared. Oh, I already have the du there. Okay, so that should be it then. So now you can see all of the players that I have listed where you have your a and then your u. Go for a different color. Need a different color. Let's go for gray. So where I have my, I already have a blue. So a u, and then you have your 3. So as that comes up in your formula on the right hand side, I won't go ahead and, but you can see there's an a, and then a cubed there, and then you have another a, and then you have a blue u, and a u here, and a u here. Almost missed it. Okay, so let's get started with this. So we have the 1/2 out front, so I'm going to put that there, put the bracket in, and then I've got an x, u is x squared. So I can go ahead and put the x squared in if I want everywhere there is. So I'm going to put the u, x squared, over 2 times a squared. 2 times a squared, I'll put in the first time, is 2 times 9, or you could write 3 squared. And then you're going to put your 3 squared plus x squared squared, which is x to the 4th. In that manner, I could have put in a 9 here and a 9 here if you wanted to. But anyhow, so I get then plus, then I have the 1 over 2 times a cubed, so that's going to be 3 cubed. And then it's going to be arctan u. So you're just really following this rule, x cubed over a is 3, and then plus the arbitrary constant c. Put the bracket in here, and then we're going to distribute our 1/2. We'll leave the 1/2 for right now, and we're going to put x squared over 18, 2 times 9, and then we have an x to the 4th. Oh, you could change this or not. Here, let's leave it the way it is. So we have 9 plus x to the 4th here. And then we have a plus, and then we have 1 over 2 times 27, so it's 1 over 54 arctan of x squared over 3 plus c, we'll call that a c1 if you will. And then we're going to multiply through by 1/2, or you could actually factor if you wanted to. You could factor out an 18, right? If you wanted to. 18 times 3 would be 10 times 3, which is 30, plus 8 times 3 is 24, 54. So we could factor out an 18 here, and we could actually leave a 1 over 36 here. Factoring an 18 out of the denominator from the two terms leaves me with an x squared over 9 plus x to the 4th, plus then we have a 1/3 arctan x squared over 3 plus c, and I'll just leave it like that. Okay, and here is the final answer. Okay, now even though I did a u sub, I didn't carry through the integral in u's, and maybe I should have, but I knew what u was already. Let me just clarify one more thing. So when I factored out the 18, it was 1/18 that I was factoring out to put it 2 times 18 to give you 36, and 18 times 3 is 54. Okay, so there you go. There you have it. There's your first problem. Probably didn't need a whole page for this. Okay, so here's the second one. Now we're using the formula. Now this is a formula where a is greater than 0. If a, you can look at Rule 17. There's another formula if a is less than 0. So number 2, using the formula. So if you notice, I started off and I said something's missing. And it's that u that's sitting in front. So I'm missing the u that's sitting in front. So remember when we have e's, e to the 2x, e to the x, it's always easy to kind of force one in somewhere. And then remember, it ends up in the numerator as well then if we multiply by 1. So it's kind of a nice little trick. So what I did is I multiplied by e to the 2x. Because I wanted that u, and the u was the same, and I'm missing that u out front. Let me make sure that my eraser's not that big. Okay, so I wanted the u right here, and it has to be the same as with the coefficient of a. It has to be the same u. So then I said, okay, a is 3, b is 4, according to this as I look at the quantities, and u is then going to be e to the 2x. So if u is e to the 2x, then du would be 2 e to the 2x dx. So then I would divide by 2, get du over 2 is equal to e to the 2x dx. And what we're going to do then is we're going to pass a 1/2 out front. So we have 1/2 the integral of, and if you notice, you have just the du left, and then I can make that e. So I can make that u here, and then the square root of 3u plus 4. Okay, so we have everything that we need here. So I'm going to put the formula down here. It's going to be 1 over the square root of b, remember b is 4, ln of, now I've got the absolute value of the square root of a, which is 3, so it's going to be 3u plus b, which is 4, minus the square root of b, which is 4, all over. It's kind of fascinating that people spend so much time and they get these formulas for these integrals. Oh, don't want that other line there. And then you've got the plus arbitrary c on the end, call it a c1, and then this is a plus sign down here. So I think we have everything except we need to go back and substitute our quantity. Oh, I am missing something, and this, recall that I've said that before, when you have that 1/2, and I know I'm going to have a 1/2, you can't forget to multiply by the 1/2. Okay, so then we get 1/4, and we multiply. we get ln, the absolute value, and we substitute back in now for the numerator, the square root of 3e to the 2x plus 4 minus 2, and then that would be the square root of 3e to the 2x plus 4 plus 2. Put that in absolute value, and then plus the arbitrary constant c. Okay, I'm going to stop this video now so it doesn't get too long, and we'll come back for part 2 of integrals using tables, and we'll talk about reduction method. Okay, have a good one.